Okay, I'm going to finish up our lesson from yesterday. I'm going to kind of go in a different order though. So you need to find this example in your notes. So example 6, and then I'm going to go back to example 5. So on this one, we're going to start off the same way we did before. So we're going to take x squared plus 2x plus blank equals, I'm subtracting the 3 to the other side, so I get a negative 3 plus blank. So again, we're subtracting the constant to the other side, and then we are setting up our blanks for completing the square. So I'm going to take half of 2. Well, half of 2 is 1, and then we're going to square a 1, which is still 1. So I'm going to add a 1 to this side. Whatever you do to one side, you do to the other. So now I can write this as a perfect square trinomial in factored form. Negative 3 plus 1 is negative 2. All right, so far everything has been the same as what we did yesterday. The next step is to square root both sides. Don't forget plus or minus. So here I get x plus 1, and here we've got a problem because we are taking the square root of a negative. So remember that the square root of negative 1 is I. So we can think of this as the square root of negative 1 times the square root of 2 when you have a square root of negative 2. So we end up with I root 2. So this becomes plus or minus I root 2. Anytime you have a negative underneath a radical sign, remember you're going to bring an I out. So then I'm going to subtract 1 to both sides. Again, you can put the minus 1 at the back, but it's more common to put it here. So we get x equals negative 1 plus or minus I root 2. And these are your answers. Remember, there are two answers here, negative 1 plus I root 2 and negative 1 minus I root 2. Now I want you to think about what would be true if you graphed this parabola, the related parabola. If you graph this, you're going to find that there are no x-intercepts. It will not cross the x-axis. How do I know that? Because when I set it equal to 0 and solved the equation, we got imaginary solutions. So that's how we would know that it's not going to cross the x-axis. I know I have this kind of set up as a, your turn, you try problem. I'm going to go ahead and do this one as well. So we're going to have x squared plus 4x plus blank equals negative 5 plus blank. So all I did was subtract the constant to the other side, set up my blanks for completing the square. Half of 4 is 2, and 2 squared is 4. I don't normally write this down if I were just working out the problem. I'm just doing that for the sake of our notes. So we have a 4 here, we have a 4 here. So now I can write this in factored form as a perfect square trinomial. Remember how to figure out what goes here. Whatever the half of 4 was 2. That's what goes there. If this is plus, this is plus. Negative 5 plus 4 is negative 1. My next step, to square root both sides. Don't forget plus or minus. So we get x plus 2 equals plus, now the square root of negative 1 is equal to I, so I get plus or minus I. I don't have a radical anymore. Now I subtract 2. I'm going to put it in the front. So I get negative 2 plus or minus I. These are my solutions. And again, if I were to graph the function y equals x squared, and you can do that if you want, you can graph this on your graphing calculator, and you're going to find that it has no x-intercepts. So always keep in mind, what the solutions tell you about the graph of the related parabola. So here we go on the last one. Well, I'm going to do a couple of them. This is going to be a problem because we have a coefficient other than 1 in front of the x squared. So we have to handle this one a little differently. So the first thing I'm going to do, let me write this down, is I'm going to divide both sides by 3 because there's a 3 in the front. So basically I'm dividing everything by 3, including the 0. So that's going to cancel these, and I'm left with x squared minus 2/3 x minus 1/3, and it's still 0. Next, we're going to do just like we did before, so except we have fractions. So we're going to have x squared minus 2/3 x plus a blank equals, I'm moving the 1/3 to the other side, plus blank. Okay, so it's the same setup. It's just you have fractions. If you need to, though, you do have a calculator. So the next thing we're going to do is we're going to take half of the middle term. So if you take half of 2/3, you get 1/3. And you can do 2/3 divided by 2 if you want to. If you take half of 2/3, you get 1/3. Of course, it's negative. So we get negative 1/3. But then remember, we have to square that. Square the top, square the bottom, you get 1/9. So I'm going to put a 1/9 here and a 1/9 here. All right, so far not so bad. So then remember we took half of this, it was negative 1/3, so x minus 1/3, quantity squared, so I'm just rewriting that in factored form. So over here we're going to have to do the math and figure out what's 1/3 plus 1/9. Remember, I want you to leave it as a fraction. You can use your calculator if you want. Common denominator is 9. So this becomes 3/9 plus 1/9, which is 4/9, and leave it as 4/9. Hopefully you see why, because my next step is to square root both sides. Don't forget plus or minus. So here we get x minus 1/3 equals plus or minus, the square root of 4 is 2, the square root of 9 is 3. So last step, add the 1/3 to both sides, so I get x equals 1/3 plus or minus 2/3. But remember, we can't just leave it like that. There's no radical in this, so we can actually work it out. So we get x equals 1/3 plus 2/3, which is 3/3, which is 1. Or x equals 1/3 minus 2/3, which is negative 1/3. Now, I want to just talk for just a minute to point out to you that this actually was factorable. If you factor this, you would have 3x times x is the only way to get 3x squared, and 1 times 1 is the only way to get 1. In order to have a negative 2x in the middle, this would have to be negative, this would have to be positive. So of course we would have 3x plus 1 equals 0, which means x is negative 1/3, or we have x minus 1 equals 0, which gives us x equals 1. So obviously, we'd rather do it that way. Remember, the completing the square process is important for other things in math as well that we will discuss. So we're learning the process, but it's going to come to a point we're going to include this on our chart. And remember, one of the parts on our chart is when should I use this method? And some of you might write in, never. But there are times where it's convenient to use the completing the square method. It will not be when there's a coefficient other than 1 in front of the x squared, because then we will have some other ways to do that. But for right now, we're still going to kind of practice and learn the process. So here's another one. I'm going to go ahead and do this one as well. So we're going to start by taking the 2x squared plus 11x plus 15 equals 0. We're going to divide everything by 2. And we get x, because that's the coefficient in front of the x squared. So we get x squared plus 11 halves x plus 15 halves equals 0. So next we're going to take x squared plus 11 halves x plus blank equals negative 15 halves plus blank. I don't know how my scroll bar got to the other side. Then the next thing we're going to do is take half of the middle term. If you take half of 11 halves, you get 11 fourths. So remember that that's an 11. We square that, so we get 121 over 16. And I know you might look at that and go, oh, I'd rather write a decimal or whatever, but no, you're going to leave it like that. So when you write this out, remember, you don't have to do any work to figure out what goes here inside the parentheses. We already know it's 11 fourths. It's what you got when you took 11 halves. You took half of 11 halves and you got 11 fourths. So, so that's what goes here. And now all we have to do is figure out this problem. So you can use your calculator if you need to. I know that the common denominator is 16, so I'm going to have to multiply this by 8 over 8. Negative 15 times 8 is negative 120, so I have negative 120 plus 121, so I get, which is 1. So I get 1/16. All right, so then I'm going to square root both sides, remembering to do plus or minus. So I get x plus 11/4 equals, the square root of 1 is 1, the square root of 16 is 4. Got to have my plus or minus though. So you square root the top, square root the bottom. So now I'm going to have x equals, I'm going to subtract the 11/4, so we get negative 11/4 plus or minus 1/4. Very conveniently, I have a common denominator already, so I get negative 11/4 plus 1/4, which is negative 10/4, and reduces to negative 5/2. So that's one of my answers. And the other answer is negative 11/4 minus 1/4, which gives me negative 12/4, which is negative 3. So those are my answers. This one also would have been factorable, and you could actually confirm that if you wanted to. You could factor this, and you would find that your two answers are negative 5/2 and negative 3. So hopefully those are the other two things I needed to cover to help you with your, you may have questions still from last night's assignment. Also, you have a few additional problems that are going to have you practice some of these.